In this video, we are going to discuss lesson 6, which is geometric sequence, and this is still part of our chapter 1, and that chapter 1 talks about sequences and series. So what is really geometric sequence? So when I say geometric sequence, it's just simply a sequence which progresses by simply multiplying a constant value called a common ratio, and that common ratio, the symbol is r. So if you have a term, let's multiply it by a certain value, then we'll get another term, then that present term will multiply it again by that the same value, and we'll get another term. So the progression of the sequence is obtained by simply multiplying by a constant value. So example here we have 2, 4, 8, 16, 32, and so on. Notice that the 2 is multiplied by 2 to get 4, 4 is multiplied by 2 to get 8, 8 is multiplied by 2 to get 16, 16 is multiplied by 2 to get 32. So the rule is just to multiply each term by 2 throughout the sequence, and this is an example of a geometric sequence. Here the multiplication of 2, the value 2, is what we call the common ratio. That is our r is just simply equals 2. So how do you simply in a certain geometric sequence, how do you simply get the value of r? So knowing that, we know already, it is already declared in a problem, it is already given that a certain sequence is a geometric sequence. How do we simply get the value of r? So just pick any term, let us say 16, then pick the term, divide it by the its previous term. So the previous term of 16 is 8, so that 16 divide 8 is 2. So the same with 32 divide 16, that's 2. 8 divide 4, that's 2. 4 divide 2, that's 2. So that's how we simply get the value of r. So this is our general term of a geometric sequence. A sub n is our desired term. Suppose we're trying to find the sequence, find the 30th term. So whatever term is that 30th term, so that is our a sub n. So our n is position of the desired term, so we say 30th term, our n is 30. A sub 1 is of course the first term, and r is what we talked about a while ago, the common ratio. So let's get to some examples. So we have here, suppose the sequence is 2, 4, 8, 16. Let's try to find the 20th term. If we're going to continue the sequence, what would be the 20th term? So let's find first our n, because we are looking for a sub n. Sure. Our n is simply 20, so this gives us, we are looking for the a sub 20 or 20th term. Our a sub 1 is 2, so meaning this is 2 times our r is simply 2, 4, 8, 16, that's still 2. Then our n is 20 minus 1, and that gives us, so by laws of exponent, 2 raised to 1 times 2 raised to 19, this becomes 2 raised to 20. If you want to, some other books consider already the final answer as to 2 raised to 20. But if you want to evaluate 2 raised to 20, that is simply 1 million. It's 1 million. Um, 48,576. So that is how we find the any term of a geometric sequence, and this is our formula or our general term. It's just very straightforward as that. Let's proceed with our second example. Suppose the sequence is 128, negative 64, positive 32, then it becomes again negative 60, and so on. what would be our 15th term? So again, let's try to find our n. Our n is actually 15, so that gives us a sub 15. Our n a sub 1 is 128, so our a sub 1 is 128 times our r. So again, going back, how do we find our r? We simply pick any term. Let us say negative 16, that's quite easier, divided by its previous term 32. If we're going to simplify this, negative 1/2, that means our r is just negative 1/2. So we have negative 1/2, and we are looking for our 15th term, so that means that is 1. So let's continue. We have 128 times this becomes negative 1/2 and 14. Just to show it completely, this becomes negative 1 raised to 14 and 2 raised to 14. So this becomes, by common sense, negative 1 raised to 14. If you're going to keep multiplying negative 1, negative 1, negative 1 14 times, you'll get a positive 1. Okay. Then 2 raised to 14, you have 16,384. Simplifying it further by multiplying that one by 128, you'll have 1/128. This is our 15th term. So that's very straightforward. Let's proceed with our third example. But this third example is somewhat of a twist. We have considered the sequence, the geometric sequence 2, 6, 18, 54, and so on. The question is, if we're going to continue the term, one of the term will be 9,565,938. But the question is, which term is that? Okay, which term is that? So which term is that 9 million talks about? You're looking for simply the value of n, because n refers to the position of this. Okay, is it the 50th term? Is it the 40th term, or what? So that's we're looking for n. So how do you do that? So the same principle. We have a sub n so we have our a sub n will become that 9 million. $9.5 million, and we don't know our n, but we know our first term, which is 2, and our r, which is 3. So do that. 6 divide 2, 6 divide 2, that's 3. So we simply substitute it there, then try to manipulate the resulting equation to solve for n. So let's try. So I have 9 million for my a sub n. Our a sub 1 is simply 2, then our r is simply 3, then we don't know n. Since this is multiplication, you can simply it's like saying 2 times 3 raised to n minus 1. So we can simply, and the right side will have 3 raised to n minus 1, and the left side will become 4,780,000 2,969. Okay, so how do we get our n? Because we are looking actually for n. What do we do is we're going to express this as base of 3. So what will be the exponent of the 3? Okay, so why base 3 and why not any other number? Because we want to express it that because this is an equation, we want the base to be the same. Basically, that's the term. We want the base to be the same. If that base is 3 here, we will express this value of base 3. So we can do trial and error. Let's say 3 raised to 5. We try 3 raised to 5. That is 243, which is very far from 4 million. Let's say 3 raised to 10. That is 59,000. 3 raised to 20. That's too much. Let us say 3 raised to 12. 3 raised to 12 is 531,000, which is getting a little bit there. Let's try 3 raised to 13. 3 raised to 13 is 1,594,000. So let's add more. Let's 3 raised to 14. Oh, that is 3 raised to 14. So 3 raised to 14 is 4,782,969. So this is 3 raised to, let's simply highlight that, 3 raised to 14. Okay, erase it here and write 3 raised to 14. So 3 raised to 14 is just 4,782,969. So the important idea here is this one. 3 raised to 14 is the same as 3 raised to n minus 1. If that's the idea, common sense will tell us that since they are equal, the 14 and n minus 1 must be equal. Okay, must be equal. So here, solving for n, you'll get 15. That means this 9 million here is the 15th term. So if you're going to continue this sequence by keeping on multiplying by 3, which is our r, in the 15th term, you will get 9,565,938. Let's proceed with our example number 4. So consider the geometric sequence 1/2, 3 over 2, 9 over 2, 27 over 2, and so on, which term is 59,449 all over 2. So the same idea a while ago. We are looking for our n. What will be our a sub n? That itself 59. What is our a sub 1? 1/2. That r. So this is the tricky part here. So let's try r. Pick any term. Let's say 3 over 2. Divide it by the previous term. And you will get 3 as your r. Okay. So here, the idea is we can multiply both sides by 2. So that 1/2 we can get from. So this is now cancelled out. This is now cancelled out. So we are left with 59 equals 3 raised to n minus 1. This is the time that we are going to express 59,049 in base 3. What would be the exponent of that? because our right side is also in base 3, the same a while ago. Okay, so what is, again, let's do trial and error using our calculator. We can say 3 raised to 9 is 19,000. 3 raised to 10, 3 raised to 10 is 59,049. So this is 3 raised to 10. So the same idea, if 3 raised to 10 is just the same as 3 raised to n minus 1, this must be equal. So we can say n minus 1 equals 10. That gives us n equals 11. That means that this term here is the 11th term. Okay, that term there is the 11th term. So that is two of the problems that we can actually solve in terms of finding the specific term of a geometric sequence. Okay, let's proceed with the geometric mean. Okay, so if we have arithmetic sequence and we have arithmetic means, we have also geometric mean. Okay, suppose we have a sub 1 here, then a certain a sub n, that middle value there, okay, and such that that middle value will be called as the geometric mean. So how do we get that? So we have here, suppose 3x 45 are terms of a geometric sequence, find the value of x. So what we learned a while ago is that if we have, let's go back to the idea of 2, 4, 8. Notice that 4 divide 2 is just the same as 8 divide 4. Okay, 8 divide 4. So we can also do this here. You say x divide 4 is just the same as, no, x divide 3 is just the same as 45 divide x. So by basic algebraic manipulation, this becomes x squared, okay, equals 3 times 45. And in turn, this becomes x equals, this is very important guys, 345. X must be positive because in that sequence it's a positive terms. Those are positive terms. Square root of 3 times 45 is 15. That gives us, this must be 15. Okay, so here is the thing. Okay, this one gives us the hint for shortcut to geometric mean. Okay, so how many numbers do we have? How many terms are we multiplying inside? That indicates our radical sign. Okay, since there are 2, this means you're just simply getting the square root. If there are 3 terms that you're trying to get the geometric mean of the 3 terms, this will be cube root. Okay, so in general we have this. Okay, in general we have this, the geometric mean, okay, of n terms. So if you have n terms, let's say when I say n terms, you have 4 terms, 5 terms, 6 terms, whatever terms, is the n root of product of that n terms. Okay, what do you mean by that? Is that if you're trying to multiply, if there are 5 terms, let's get the fifth root of that product of that 5 terms. So meaning, multiply the 5 terms, get the fifth root of that. So the fifth root, because you have 5 terms. If you have 4 terms, simply get the fourth root of that product of that, meaning product multiply product of the 4 terms. So that is how simply works. So let's try with this next example. We have here we have two terms. We can simply say find the GM of this. So the GM will be simply there are two terms. We're trying to say square root of 3 times 8. Multiply the two terms. So that is square root of 24. That is roughly 4 point something, almost 5. That is 4.9. Okay, so here the GM, since we're getting the geometric mean of these three terms, we have the cube root of 4 times 7 times 11. So you can simply multiply 4 times 7 times 11, then get the cube root of that. That is 4 times 7 times 11. That's 6.75. That is our geometric mean. So let us say here we have 25, 19, 12, 20, 25. There are four terms, so we say the geometric mean of this is the fourth root of the product of 9 times 12 times 20 times 25. That is fourth root of the product of 9 times 12 times 20 and times 25. 15.24. So the geometric mean is just simply 15.24. Okay, so simply as that, that is our lesson 6, the geometric sequence.